Hello everyone, I'm Akshay Jain. I'm engineering manager at the Innovate UK. Innovate UK is a government-backed VC fund which helps organizations by providing them of funding to execute their projects. At present, I work with the data migration projects where the primary responsibility includes around executing a data migrations, data integrations, and the implementation of some of the NLP techniques to help them resolve some of the machine learning related use cases. Topic for today's talk is topic modeling for text documentation using NLP techniques. In this particular seminar, I'm just going to share my journey, how we are trying to solve some of the use cases that we have around the text document analysis and how we are solving it using the NLP techniques. So yeah, let me just walk you through to some of the use cases and the challenges that we have. And post that, I will be just throwing at you some of the solutions and the things which we are implementing to meet those particular challenges. Yeah, let me just go back to the use cases. So on the use cases side, primarily we have four kind of use cases right now to solve. The first use case is how we can identify the entity's name within the documentations. So generally what happens is that as it is a venture capitalist company, lots of people submit their applications in with an intention to raise a fund. So lots of documentation comes in a way where people provide information such as what is the description, what is the purpose of their work and things like that. So all of those things come in the form of a large documentations. And what we try to identify in the document is what is the kind of all different entities and things are involved. Just to identify we are not putting government money to any of the sanctioned companies or sanctioned persons or something like that. The second kind of use cases, what we have is that whatever applications or things we are getting in that data, we may want to identify whether the documents have a certain similarity or not. We have a two purpose for it. To just identify what are the different segments or industry sectors in which we are getting a different application. And the second one is to identify the use cases where people are submitting one applications multiple times with the word changes and things like that in a way. So we don't spend much effort to assess those applications again and again in a manner. So that's the kind of second use case we have, where the purpose is to clean the application data and identify the similarity between the documents. The third use case what we have is to understand what are the sectors and things in people are submitting their applications, how those applications are related to each other from the industrial sector perspective, and where the funding and the things are coming in a way just to understand the market conditions. And the fourth use case we have is to support a kind of ecosystem where we can say that in which particular subcategory under the industry codes, the more and more money is getting funded or more and more application which is coming in the market. So from all those aspects, we just try to identify and we try to analyze all the applications that we are getting. And for that purposes, we are trying to build a system which can help us resolve all of this kind of problem and give us a concrete solution around it in a particular way. So let me just walk you through the journey where we have solved some of these use cases and some of the use cases are still undergoing progression. So I'll be just walking you through that journey in that particular sense. The first use case we have is to identify the entity within the documents. We generally have lots of textual information in our documents. What is the purpose of the fundraising? How it is going to help them? Then what they have did till now, what kind of product they are building, what kind of partnerships they have, what are the people, what are the different peoples and entity that is involved in those things. So we get generally lots of textual informations in the form of text and documentation from them. On those kind of things, what we try to identify is that what is the kind of entities that are involved in over here in terms of what is the country from which the funding is asked, what are the people who are asking for funding, and some more textual information that we just want to identify from those documents is to ensure that we are working on the applications as per the government guideline and no compliance related issues and things are happening over there in that case. So in those particular cases, one of the things what we have done is whatever documentation and text we are getting, like this is one of the example of the text which I have just randomly took from the internet out of one of the news article, where it is specifically mentioning something about the Andy Murray and how the things are going on tennis side of the things. So I've just randomly took an extract out of it. And on this particular extract, if I want to identify that what are the entities that has been involved over here in terms of a people, country, date, and other factors. What I can do is I can just use some of the available NLP libraries to identify those kind of information. One of the library that support identification of all these clinical details with a very minimal usage of coding is a spacey library. And in the spacey library, what we can do is we can just take a spacey library, we can just load a model, whatever we like to use. Spacey library provide multiple models, like here in this example, I'm just showing you the usage of NCode Web Large Language Model. You can use any other language model as well, whatever works for you. There are specific language model that has been built to analyze the news related articles, web related details and things like that. So you can just choose what kind of LL model is working best for you, and you can just basically load that model into the spacey. And after you just load that model, what you can do is you can very easily analyze the textual information using this particular library. And this library is going to provide you details that what is the kind of entities and entity types are involved in that particular document based on the supported entity types. So if I just go over here and run this particular code in the article that I have just shown you earlier, what it is going to do is it is going to provide me an output which is going to look something like this, where it is just going to show me that in this particular article, these are all the different persons that are involved. These are the geopolitical locations that have been identified in this particular article. It has identified the location as Dubai over here, as you can see. Event it is able to identify, for example, the Qatar Open is one of the event which it has identified. It is also providing us a detail about the various dates related details, like whether it's a particular day or something related to day. Those kind of detail it is providing. Also, it is able to identify some of the cardinals or the numerical information that we have within it, like 2 or 6 or any other numbers and things like that, whatever is presented over here. So those kind of information is something which we can very easily identify. And once we identify, this information can be stored for querying purposes, just to check whether a particular kind of entities or person or organization names or something like that is involved in a particular application or not. Spacey inbuilt support all this kind of different entity types like person, organizations, geopolitical locations, products, law, date, time, etc. You would be able to differentiate whatever textual information you have within this particular categories. And based on that, basically, you would be able to store this data and can be used then further for querying purposes to perform some of the compliance related checks and things like that. This is like one of the way in which we have started the thing using in a way, and we are just progressing further on it to use the information in this particular manner. Now, the next use case what we have is to identify the similar documents. As I mentioned a scenario, what happened is that the application gets submitted, and that application generally go through a cycle where the application get reviewed and reviewed by the multiple subject matter expert depending on in which field people are looking for funding for and things like that. It basically analyzed in that particular way, and based on that, generally the decision is taken whether to give a funding or not and things like that. What the general scenario what we see is that people submit the applications. If the application got rejected, they just go and make a wordy changes over here and there. They change some words, they make a paragraph over here and there, and add some more additional details over here and there, and then resubmit the applications. So what we basically try to identify over here is that how two applications are similar to each other. And if those applications are similar, or if those applications are submitted across the multiple categories or things like that, then we just want to identify those kind of applications. So we basically arrange and manage them properly. So in order to identify again those kind of textual informations and the details, we basically use a two kind of methodology. The first methodology is to use the inbuilt functionality of a specific kind of library, where we are again going to use some kind of large language model, and in that large language model, when we are going to provide it a particular document as an input, on those particular documents, it basically processes the documentation, apply the inbuilt algorithm on it, which is primarily towards the TF-IDF kind of algorithm-based scenarios, and then possibly application of vectorization on it. And based on that, as an output, it will provide us a detail that how these two documents or these two information which is mentioned on those text documents are similar to each other. And if that particular match has crossed a certain threshold, then we just flag that these two applications can be similar across categories. Or if, let's say, in the future, an application is rejected, which has a similarity to the current application, then we basically process it in a different way to do a further deep dive on it, that whether this application is again submitted from the same source with some changes or it is a new application altogether. So those kind of use cases which we can just solve with this kind of functionality. And as a part of a special library, this particular functionality come inbuilt. So without writing a very minimal amount of code, we basically solve this particular problem and identify a solution in a particular way. So like here in this example, you can see that the first sentence is I like salty fries and hamburgers, and the second one is fast food tastes very good. So in this particular way, it basically take those words, apply the lematizations and the tokenization related techniques on it to identify word like how they are similar to each other and bring the forms and bring the words in its original format, and then it will just calculate the similarity score on it. So based on that, you can just see the similarity scores that it has generated, and the score is something that can be used further to identify the things at a particular level. Generally, what happens is that when we go and we apply any kind of this kind of processes, if we are applying it with a spatial libraries or things like that, it is good to apply directly on the raw data to a certain extent, because to a certain way, spatial library use some of the internal algorithms to implement the tokenization and the lemmatization kind of functionality before applying the respective algorithms. So the things can work out very smooth over there. But in general use cases, whenever if we are going for a more further use cases where let's say we trying to implement some advanced logic over there to identify the text documentation based out of the cosine transformation related algorithms and the vectorization techniques like that. In those cases, the initial thing what we generally do is we pre-process the text information, and in that text information we basically apply some kind of data cleansing in terms of making ensure that everything is in lowercase. We stop the punctuations and the generally use words. We also apply the tokenizations and the lemmatization. So lemmatization, what it generally do is it basically bring the words within the sentence to its root, so that when we are comparing the words and the things like that particular common become on the same level playing field. And further that, if we are applying any kind of algorithm, like for example, let's say we are applying a TF-IDF, some kind of n-gram technique or something like that, then those kind of calculations become very effective over there to calculate the score and the further usage. There are some of the techniques which we can be used, and for that, like NLTK is a general library which provides lots of functionality to implement those kind of use cases with a very minimal amount of coding and things like that. Now, once we basically clean the data, after that, we go to the other use cases, where in this particular use case, what generally happens is that at the next level, what we try to identify is that whatever applications and the details and the textual information we are getting, how that particular information is segregated across the different industry sectors and things like that. So we understand that from which particular sectors more and more funding requirements are coming, or what kind of growth we are seeing. So A, we can understand the industry trend, and B, we can basically manage our capacity to access those applications and things in a particular way. So in order to perform those kind of things, we basically manage or we are building a kind of techniques using a clustering algorithms, which basically help us identify that whatever textual information we are getting, that textual informations belong to which particular clusters. In order to build and take this particular count, as I mentioned earlier, we basically first go and we basically first clean the data. After cleaning those data, we basically apply some kind of vectorizations on it. And after we do this particular vectorizations, we basically go for algorithms to cluster them in a way to see, what kind of clustering is working best for us. We have initially started with the k-means clustering. Within the k-means clustering, this is one of the output which is there on the with some sample data, where we can see very clearly that with the k-means clustering, we are able to basically input that data, and we were able to basically tell that what are the kind of clusters and things those applications belong in a particular way. And based on that, basically, that can be used further. And the segmentation can just help us to understand the application in a proper way. The other things, what happen is, or why we need this particular thing is, because there are chances that a company is working in a sector A, but when they basically submit the applications and the details, those application may belong to sector B. So those kind of things are very general in nature because companies are doing generally an innovation either in their field or in some other fields as well. So we basically try to capture those things, and we also try to understand that what are the kind of overlap we are seeing between the industries in terms of innovation and the kind of things they are doing. So this kind of clustering techniques basically help us identify those kind of things and provide an answer more on that side. So here basically K-means is one of the clustering techniques that we have used, and in that way basically it has worked very well out for us to segregate the data in a certain way. Other thing what we have tried out is a fuzzy ceiling clustering, which has comparatively generated a better output for our data sets because of the characteristic of the data and how the words in the textual information is connected to each other in the vector arrays. So based on those particular inputs, we were able to basically generate a clusters and the things out of it to understand those particular things in a more appropriate manner. Now, based out of this particular information, we are now able to confidently basically categorize the data, and we can just say that, yeah, these are the kind of industry categories and the things that these applications belong to, and they can be used further on that side. All of these things are implemented generally using a Python library. With that, basically, we can just build the pipelines on the top of the AWS using the SageMaker notebooks or something like that. And in that way, basically, this build things can be solved in a particular manner. Along with this thing, the other thing what also we want to identify is that whatever things we are getting and whatever things we are getting in our cluster, those things are similar to each other, and how those things are in general helping us out to identify the things in a particular way. In order to identify those kind of details and some of the scenarios around it, what we generally do is that on after doing a clustering of those applications, we also basically go and generate diagrams and diagrams on the top of it to identify the frequently used keywords and the things that are present on those particular clusters. And using the available libraries and the techniques around it, we are basically able to implement those kind of details and identify what are the common keywords and things we are seeing. And there are certain set of keywords which we basically take out of it just to understand that these are the highest highly used keywords in these applications and the things like that. So this we can just implement using this diagram and diagram techniques, and we can also around that get us some kind of informations on a dummy data, like the number you can just see over here for some of the dummy data, that you know how those particular tags are being used, what are the kind of instances we are seeing over here, generally the term frequencies and the inverse term frequency kind of scenarios in this manner. And we basically just see that how those terms are being used across application to understand the application similarity, dependency, and the sectors influence on each other. So in that way, basically it helps us get those information and process further on those particular sites. So once we basically get this particular information at the next level, this is something which is in progress. We are still working on it. And this is something like what we are trying to identify is that, okay, where we have identified what are the clusters we are having. We have identified like what is the kind of topics we are having in that particular clusters. But the missing part is that what is the kind of hierarchy that exists between those particular topics or cluster that has been present over there in that particular way. So for that purpose, we are just experimenting with some of the algorithms and the techniques around it to identify those things. Like one of the algorithm which we have used right now is related to the agglomerative clustering techniques. So with this technique, we are just trying to understand that how these topics and things are related to each other, and whether we are able to build some kind of a graph around those things or not. Where at the root node, maybe we can just see a cluster as a category. At a sub level, we can see this different hierarchy. And at the end, or at the root level, we can just see the different tags or topics that has been identified within that cluster. So we can just use it in a particular manner. So this is again in a progress, and mostly once we crack it in a future video related to machine learning or something like that, I would be happy to share those kind of instances in terms of what is worked out and what is not. Right now, the results which we are seeing on this particular technique using agglomerative clustering is not that much satisfactory. We are trying to improve it with other things and things like that. Yeah. So that's how we are basically trying to solve the use cases around the machine learning using a topic modeling. And in order to build this particular things, we are generally using most of the open source Python libraries. And in order to perform this particular clustering related techniques, or sorry, not clustering but the diagrams and the diagrams related technique, we have also gotten exposure to different libraries like Keybird or something. And those libraries are generating a reasonable amount of results. But one of the things what you identified is that rather than going for a keyword libraries and the other Hugging Face and respective library, we in our experience we basically for a particular domain we got a more positive results by using the basic Python techniques around the diagram anagrams and the term frequency idea related techniques and things like that. So yeah, that's all about this particular presentation, and my goal was just to provide you in detail in terms of what are the kind of use cases exist and what are the kind of approach and things generally work out in the industry in that particular manner. So yeah, that's all from me in the today's presentation. If you guys want to learn more about it or just want to be in touch, please, these are my contact details. Feel free to connect with me on the LinkedIn or feel free to connect with me on the email to discuss any of the possible challenges or things that you would like to discuss around the use of topic modeling and the NLP use cases around it. And I would be happy to connect and share more details over there in that particular way. So thank you. Thank you for your time and thank you for listening this particular session. Thank you.